Good morning, Year 4. I hope you're well and welcome to today's maths lesson. We are going to be looking at equivalent fractions for the final time today, and we will be using something called proportional reasoning to help us to find equivalent fractions a bit quicker than using any of the models that we've previously looked at. Now, we do have some daily fluency questions today. Can you spend no more than 3 minutes answering these, please? So pause the video now, 3 minutes answering the following 3 questions. Off you go. Okay, number 1, what is the missing numerator? Well, if we know that 3 multiplied by what gives us 12, we know that 3 multiplied by 4 gives us 12, then 2 multiplied by 4 gives us 8 over 12. Alternatively, you could have drawn one bar showing is split into 3 parts and one bar split into 12 equal parts, and you could have shaded in your 2 of your 3 parts and your 8 of your, you would have found that that would be the same as 8 over 12. Number 2, what is the area of a rectangle with 3 rows of 2 squares? Well, that would be 6 squares. And finally, 1,000 more than 3,813 is 4,813. Make sure you're looking at that more or less. If it's more, the number is getting bigger. Super job. So I have got just 3 more questions for you today to help you with your learning for today's lesson. So the first, well, they're all using the different models that we've used so far to find the equivalent fractions. So can you pause the video now and use the 3 models to find the equivalent fractions, please? Off you go. Okay, so we want to find out 5/6 is equivalent to how many 12ths. So we can use the first bar and colour in 5 of those 6ths. And then we could split the second bar into 12 and colour in however many 12s would make it equal. And we can see that 10 12ths is equivalent to 5/6. Alternatively, we could use a number line to work out 9 12ths is equivalent to how many quarters. We can see the top part of the number line has been split into 12ths. Counting along, 9 12ths would be here. Then we would count how many quarters we have. 1, 2, 3 quarters. So that is equivalent to 3 quarters. And finally, 2/3 is equivalent to how many ninths? We can use our third section on our fraction wall. We can find 2/3 here, draw a line to the ninths, and we could find that it is 6/9. Okay, so we have looked at a variety of different methods so far, and we're going to continue looking at the bar model. But this time, we're going to look at this question here. 1/3 is equivalent to how many 6ths? Now, we don't have 2 bar models here, so we have to split this bar model into 6. Now, we know that we could split the bar into 6 by adding one line, and that line could either be downwards, meaning that we have 2 6ths, or we could have another bar and we could split it horizontally, and that would still mean we get 2 6ths. Now, why have I chosen to split my bar into 2? Why have I chosen to choose each third and split that in half? That's right, because 3 is half of 6. 6 is 3 doubled, so we would split our parts into half each, giving us 2 6ths. Now this time we want to work out 2/3 is equivalent to how many ninths. Pause the video. How many parts am I going to have to split each bar into, and how many parts would I get out of 9 if I split it vertically, and how many parts would I get if I split it horizontally? Pause the video now and have a think. Okay, did you work out that we have to multiply 3 by 3 to get to 9? So we would need to split each of these parts and making sure there are 3 parts for each third. So we could split it, firstly, we could split it vertically. And how many ninths is equivalent to 2/3? We have got 6/9. Or we could split it horizontally and see that we've also got 6/9 too. Now it's your turn. Can you pause the video here and have a go at the questions 1 and 2 on the worksheet, working on how to split each of the bars in a different way to make sure that you are finding the equivalent fractions. Okay, so pause the video and off you go. Okay, so we've been using different methods to work out how to find equivalent fractions so far. Now we've been looking at the bar model, so cutting the bar into different sections. We've done this by looking at shapes as well, cutting the shapes into different sections. We've also used the number line and we used the fractions wall. Now I want to find the equivalent fraction to 4/5. I know it's going to be something over 10, but I would like you now to have a practice at using each of the different representations to find the equivalent fraction. So can you pause the video now and have a think how you would use the fraction wall, the number line and the bar model to work this out, please? Off you go. Okay, so we could use the bar model to find this because we can see that it's already split into 5 sections. We could colour in 4 of these sections showing 5/5. We could then do what we practiced earlier and know that 5 is half of 10. So each of these parts must be split into 2, giving us 8/10. We could do the same with our circle here, which is already split into 4 out of the 5 parts. Again, knowing that there are 5 parts so far and we need to make 10, we could split each of these parts into 2, giving us 8/10. Now looking at the number line, we can see that the top half of the number line is showing fifths. We could count along and find 4/5 on our number line, and then we could use the bottom half of the number line representing our tenths to count along, and we will find that we have 8/10 before that place. And finally, we could use our fraction wall to find 4/5, looking at the dusky blue section, drawing that line down with a ruler and seeing that it lines up on my green bar, which represents my tenths, and before that comes 8. So we can see that 4/5 is equivalent to 8/10. Now I'm going to show you another way that we can find equivalent fractions, which makes it a little bit easier for you, because what you can do is you can use proportional reasoning to help you. This is where whatever you do to your numerator for your first fraction, you must do for your denominator for that fraction too. Now, I would like you to have a think of these two fractions. 4/5 is equivalent to 8/10. What do you notice about my numerator and my denominator? Pause the video and have a think. Okay, let's see if you noticed what I noticed. Did you notice that to get from 4 to 8, we have to multiply 4 by 2? And to get from 5 to 10, we have to multiply that by 2 as well. Now, look at these two on the screen in front of you. 1/3 is equivalent to 2/6. What do I need to multiply my numerator 1 by to get to 2? That's right, I have to multiply it by 2. And what do I have to multiply my denominator by to get from 3 to 6? 2 as well. Can you notice that whatever I've done to my denominator or my numerator, I have to do to my denominator or numerator again? Similarly then, to get from 2 to 6, what do I multiply by? 2 multiplied by what gives me 6? That's right, 2 multiplied by 3 gives me 6. And what multiplied by something gives me 9? Well, 3 multiplied by 3 gives me 9. Now you can see that on my diagram, just looking at the top equivalent fractions before we move on to the next ones, we could also do the inverse, because we know what is the inverse of multiplication? Division. Fantastic. So 2 divided by what gives me 1? That's right, 2 divided by 2 gives me 1. And 6 divided by 2 also gives me 3. So I can see that as long as I'm doing the same to my top number, my numerator, as my denominator, then I'm going to get the answer correct. Now looking at the bottom one, we've already said that we can multiply them both by 3. So in that case then, what are we going to divide by 3 to get from 6 to 2? That's right, we're going to divide by 3 too. Now, I've got my equivalent fraction here. 3/4 is equivalent to how many eighths? Can you use the proportional reasoning method to work out how do we get from 4 to 8? What do we multiply? And do the same to the top one to work out the equivalent fraction. Pause the video and have a go. Okay, let's see if you're right. But first, Tiny the Turtle has suggested that it's going to be 7/8. Do you agree? Tiny the turtle thinks that because we've added 4 to get from 4 to 8, we need to add 4 to get from 3 to 7. But let's have a look if Tiny is correct. So we have our bar models. The first one is 4 split into 3, a bar model split into 4 parts. 3 parts are shaded. And my second example is a bar model split into 8 and 7 of the parts are shaded. Are these bar models equivalent fractions? No, they're not, are they? What has Tiny done incorrectly? That's right, he hasn't used the correct method. He has added when actually you're meant to either multiply or divide. So what should the correct answer be? Well, we can see that it should be 6/8 because 4 multiplied by 2 gives us 8. Therefore, 3 multiplied by 2 gives us 6. Thank you for helping me with that one, Year 4. Now I would like you to have a go at using either multiplication or division to work out the equivalent fractions, please. So pause the video, have a pen and paper on hand and write down the equivalent fractions, please. Pause the video now and have a go. Okay, how did you do? How do we get from 4 to 16? What do we have to multiply? Shall we count in our 4s? Ready? 4, 8, 12, 16. We have to multiply it by 4. So we need to multiply 3 by 4. What is 3 multiplied by 4? Let's do this together too. 3, 6, 9, 12. So I can see that this fraction would be 12 over 16. Similarly, with number 2, 2/9 is equivalent to 6 what? Now, how do we get from 2 to 6? Well, we add 4, don't we? Oh no, we do that, but we need to multiply. 2 multiplied by what gives me 6? Let's have a go. 2, 4, 6. 2 multiplied by 3 gives me 6. So we need to multiply 9 by 3. What's 9 multiplied by 3? 27. On this one, we can see that how do we get from 14 back to 7? How many 7s are in 14? There are 2, so we are dividing by 2. So what is 20 divided by 2? That's right, it's 10, so it'll be 7/10. And finally, with this last one, you can multiply and divide by whatever numbers you want as long as they're the same. Let me show you a few examples, because we don't have a numerator or denominator to work with, so the rule is endless. We could choose to multiply both by 2, giving us 6/14. Alternatively, we could multiply both by 12, giving us 36/84. We could also multiply it by 100, giving us 300 over 700. So it really doesn't matter what we multiply or divide it by, as long as we are multiplying or dividing by the same number for the numerator and the denominator, we will get an equivalent fraction. Now it's your turn to have a go at the rest of the questions on today's worksheets. Take your time and work your way through them, please. Pause the video now and resume when you've finished those. Okay, the final part to your math lesson today is to tackle those reasoning and problem solving questions. So I would like you to have a go at the following 2 questions to complete the math lesson. The first one gives you some digit cards. You can only use these numbers, but you need to try and complete as many equivalent fractions as you can. Can I use the number 9? No. Can I use the number 5? No. Only 1, 2, 3, 4, 6 and 8. Your second job today is Tommy is finding equivalent fractions, and he said that I did the same thing to my numerator and the denominator, so my fractions are equivalent. Are they? Do you agree? Remember to explain and actually think, well, what has Tommy maybe done incorrectly? What should he change? Okay, so those are your final 2 tasks for today's lesson. Super listening today, Year 4. Thank you, and I will see you in our next lesson. Goodbye.